we're going to go back to talking about simulations. So today we're going to learn how to model equally likely outcomes and unequally likely outcomes. So what a simulation is a simulation is going to be an experiment that is designed to model the action in a given simulation. So for example, we could use a random number generator to simulate rolling of a number cube. Simulations are often used to model to act out an event that would be impractical to perform. So a lot of times they use coins, spinners, dice, or they just have like different colored marbles. So we just want to make sure that the number of options matches. So for example, let's say that I wanted to choose a true false test. So and I wanted to randomly choose what answers would be on a true false test. I could use a coin to do so. If I was going to use a coin, I could just assign true as heads and tails as false or vice versa. I could use a spinner. I would just have to have two sections on the spinner, one true, one false. If I wanted to have more than two sections, obviously I would just have to make sure half of them exactly are true and half of them exactly are false. I could roll a dice where I could have all of the even numbers be true and all the odd numbers be false. I could have 1 to 3 be true and 4 to 6 be false. Or I could just choose different colored marbles or popsicle sticks, whatever I want to do. Have all the red ones be true and all the blue ones be false. Whatever I choose, again, I just need to make sure that the number of options matches. So if I have only two answer choices, I need to make sure whatever I do on my coin, my spinner, my dice, or whatever other idea I would come up with only has two options. Now, let's say, for example, though, that I now have a multiple choice test with the answers A, B, C, or D. So again, I could go through and I can use a simulation to generate that. So if I were to use coins, this time I couldn't just use one coin. However, we learned the other day that if I flip two coins, then I would have four different options. I can get heads, 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 tails, tails, heads, and oh, sorry, I clicked the wrong button, and tails, tails. So I could have like A be heads, heads, B be heads, tails, and so on. I could design a spinner where my spinner would be divided into four equal sections this time. So I could go ahead and I could have like a quarter of the circle be A, a quarter be B, a quarter be C, and another quarter be D. Again, I want to have four different outcomes and I need to make sure that they all are equally likely to happen. So they all have the same exact size. So again, I could have a four section spinner and I could have A, B, C, D. I'll come back to dice in a second. I could choose different colored marbles though, where I just have four different colored marbles, again, because I want the number of options to match. So I could have four different colored marbles, four different colored popsicle sticks. If I wanted to use more than four, I just need to have a fraction that simplifies down to 1/4. So if I were going to have 20, I would just need to make sure I had five of each color, because that would equal 1/4 of them being each of the different answer choices. Now, a dice, I could technically use a dice. I just have to get a little bit more creative with it. I could have number 1 be A, 2 be B, 3 be C, 4 be D, and then 5 and 6 just mean I roll again. So dice works not as well as the other ones, but you could still make a dice work. Again, there's also lots of other options you could use as well. Let's use this specific idea though of if you guys have ever gotten cereal boxes with prizes inside, this cereal company is placing one of 8 different cereal trading cards in its boxes of cereal. So if each card is likely to appear in the box of cereal, I want to describe a model that could be used to simulate the cards you would find in 15 different boxes of cereal. Now, it's kind of impractical to go out and buy 15 boxes of cereal just to open them up to see what trading card you'd get. Okay, I don't think most parents would want to be buying that much cereal, and we kind of just don't need to be stocking up on cereal like that. It's kind of a waste right now at this time, unless you have a very hungry family who just eats cereal all day long. So we need to kind of come up with an idea of something that could be used in its place to simulate this. We could, you know, make a spinner that has 8 different sections on it, 1, 2, 3, 4, 5, 6, 7, 8 to represent the 8 different cards. We could have 8 different colored marbles or popsicle sticks that we could pick, each color representing a different one. The dice would be kind of hard here because unless you have an 8-sided dice, so that really wouldn't work out that great. But we also learned the other day that if I flip 3 coins when we made our tree diagram, that I could have 8 outcomes there. So I'm going to use that for my simulation today. So if I have, and I don't know why the E is not there, that's a screenshotted directly from the book. So that kind of bothers me every year that it's missing. But if I have H, 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 that's going to represent card 1. If I get H on the first coin flip and then H on the second one and T on the third one, that's going to represent card 2 and so on. Normally in class, we'd go and I'd have you guys come up and flip a real coin to do this simulation. Since we are not in class right now, I do have this website which you guys are going to be able to use today on your assignments if you do not have an actual coin at home to be flipping. So I'm going to flip this 3 times. So I got heads, heads, and tails. So then I would go back and I would look at my chart, and here I would get heads, heads, tails. So heads, heads, tails, if I look at my chart, would be number 2. So I just won card number 2. So let's try this again. I would do tails, tails, and heads. So then I would go, and again, I would just say I got tails, tails, heads. So then in my simulation, if I look at my chart, that means I would have won card 6. Now, I'm not going to waste your time actually doing this 15 times, but you can see how this simulation will work, and we could pretend like what cards that we would have gotten. Okay, if we actually were to do this 15 times, or even 8 times, we should have, in theory, gotten each card 1 time, because right now, each card has a 1 out of 8 chance of happening. If we were to actually do this 8 times, which again, I'm not going to waste your time, but feel free at home to do this simulation yourself if you can find a coin and to flip it, 3 times and then do that 8 times and see, do you get each card exactly 1 time? We've never had that happen when we perform this experiment in class. So now I want you guys to try to think of a simulation real quick. So if each student who volunteers at the concession stand gets a free school t-shirt, and the t-shirt comes in 3 different designs. So I want you guys to think of right now, what kind of simulation could you do that would have 3 different outcomes? So how could I have a simulation to predict what shirt design each student was going to get? So I want you guys to kind of think of an idea and type it in the box for me right now. So, some ideas students normally come up with is that you could have obviously a 3 section spinner with each of the shirt designs on there. You could have a dice where you could say like 1 and 2 is a design. You could have 3 and 4 is another design, and 5 and 6 is another design. So you could kind of set it up that way. With the dice, there's other ways you could use the dice as well. That's just one of the more common ways. I could have 3 different, like, colored marbles that would work out there as long as they're different colors. You know, um, Flipping coins sometimes is a little bit trickier, but sometimes some kids come up with ideas with that where they flip 2 coins and then heads, heads is one design, heads, tails, tails, heads, and then if they get tails, tails, they just flip the coins again. So I'm interested to read what you guys came up with here. Let's try one more simulation that you guys are going to design. So sometimes the simulations to use to model events in which the outcomes are not equally likely. So there's a 60% chance of rain for each of the next 2 days. So I want to find a method to use so the experimental probability of having rain on both the next 2 days. So if it's a 60%, I don't want things that are going to be 50-50 anymore. So a coin flip is not going to be my best idea right now. But I know that 60% is the same thing as 6 out of 10 or 3 out of 5. So I want to come up with something that's going to have a 3/5 or a 6 out of 10 probability. So again, I could design a spinner that's divided into 6 equal sections, or sorry, 5 equal sections. It's going to be really hard to show you on here, but I could have a spinner that's divided into 5 equal sections. And we're just going to pretend like my sections are even here because, guys, this is hard to do in person on the smartboard. It's even harder to do on my computer screen. So let's pretend like those are all equal sections. And I could just, instead of labeling half of them, because obviously I don't have half, I could just say rain on 3 of these. And then I could have no rain on 2 of them. And then I could spin my spinner and see what happens. Now I could put these in any order. I don't have to put all the rain and no rain right together. So I could come up with a spinner. I could also have, different colored marbles again. I could have, 6 one color and 4 another color, or 3 and 2, however I wanted to set this up. Lots of different ideas. The main thing to recognize is that you always want to have the number of options matching for your simulation. So I'm going to have you guys try out a couple of things today on Desmos and a quick Google form with some questions. So good luck with all this.